Next question is assertion and reason. Assertion A. In a power plant working on a Rankine cycle, Rankine cycle, the regenerative feed water heating improves the efficiency of the steam turbine. That is assertion. What is the reason? Reason is the regenerative feed water heating raises the average temperature of heat addition in the Rankine cycle. So here what is the assertion? Assertion in a Rankine cycle, whenever you use the regeneration, they are saying that the efficiency increases. Why? What is the reason? The reason is in regeneration, the mean temperature or the average temperature at Q1 means heat addition, increases. Because of that, efficiency increases. Of course, that is what we have seen in the theory. It is a straight away problem. But still, see, this is correct statement, and for this, the reason is correct here. So, what is the option? Both A and R are correct, and R is the correct reason for the A. So option is A. Answer is A here. Answer is A here. Okay. So what are the other processes that will increase the mean temperature? Other one is superheating, and next one is increasing the pressure in the boiler, and sometimes reheat also, but reheat is again we need to debate deeply whether it is really increasing the mu or not. Okay, so these are the three compulsory processes that is increasing the mean temperature at Q1. So here I will spend some more time. What exactly happening in case of the simple regeneration? In case of the simple regeneration, what is happening? See, this is the TS diagram. In this TS diagram, let's assume only this process. I am not considering the superheating. Without superheating, I am considering. So this is the process. So 1, 2, 3, 4. So these are the arrow marks. So here what is happening? This is a simple Rankine cycle. In this simple Rankine cycle, where could be the mean temperature? Ideally, see, Q1 is from here to here and then here to here. So this portion is below this. So what happened? This is the TM1. So this line will become TM1. M1 means for the simple one. Now what I do, I will use the regeneration. So if you can recollect from our simple regeneration theory, whenever I use this simple regeneration, then what is happening? In case of regeneration, what is happening? I will take out some of the steam from the turbine, and I will use that for the heating of the liquid before it enter to the boiler. That is what I am doing. So because of that, what is happening in the turbine? The turbine is no longer the reversible adiabatic. Adiabatic means constant, so there is no transfer of heat. But whereas here in this case, because of the regeneration, there is a transfer of heat, so it is no longer the isentropic or the reversible adiabatic, but instead it will follow this line. So let's assume I will draw this little bit like this for the sake of our understanding. So here, so it will follow here, it will follow the same line like this. It will follow the same line like this. So instead of 1 and 2, it will follow the 1, 2 dash. Now this is the 1, and here there are two more assumptions. What are those two more assumptions? Whatever you tell me. Here the amount of heat transfer are always same. So delta T of water equal to delta T of steam always. This is the steam region, this is the water region, and there is one more assumption. What is that? Delta S of water equal to delta S of steam. Of course, you don't worry about the symbol here, negative value. Actually delta T, how we equated this from the delta Q. So here, apart from that, we also saw that the simple regeneration process, the efficiency is becoming, let's assume this is the T1 and this is the T2, the efficiency will become, T2 divided by T1. So what is the meaning of that? This means, the simple regeneration cycle, okay, is making the Rankine cycle into the Carnot cycle. Okay, that means, whenever it is making into Carnot cycle, always what is happening? Its efficiency increases. Why? Because the Carnot cycle is the ultimate cycle which is having the maximum efficiency. Okay. So what exactly happening here? Here the exact thing that is happening here is, the heat transfer from this point to this point. Let's assume this is the point 5. This is avoided. There is no heat transfer from here to here. In that case, what is happening? The heat, then in that case, Tm2 is becoming the T1 here. That means, from here to here, heat addition is at a constant temperature here. And where is the heat rejection? Heat rejection is at this position. Okay, this is a heat rejection Q2, which is at a constant temperature. So heat reduction and heat rejection and heat addition both are at the constant temperature. So is it ringing any bell to you? Yes, it is a Carnot cycle. Okay. So that is why it is a Rankine will become, or Carnotization of the Rankine cycle is possible only with the regeneration. Okay, in the process what is happening here? The mean temperature increasing, mean temperature at a heat addition is increasing. That is a simple reason, and actually these are the assumption, and this is what actually happening. Okay, I am explaining again and again so that it will go into brain. Don't by heart any concept, you always learn the concept so that whatever the twisted question comes, you should not miss the mark.